In this video, I am going to show you a very important concept of from the legendary polynomial through which will able to deduct the legendary first order, second order polynomial. Watch this video until the end. You will get the insightful view of a legendary polynomial, and it is easy to remember for how to find a legendary polynomial. And we will prove it through the proof. I will show how it work on a legendary polynomial. So if you are before starting this video, if you are new on my channel, have not yet subscribed to the channel, not following my page and follow the page immediately, and follow me Twitter and Instagram and other social media where I upload a post when I get free from this. So let's get started. Our very important is Rodrigues formula. Rodrigues formula. What is Rodrigues formula? It is said that the polynomial px is the legendary polynomial. It is nothing but 2 to the power n factorial d by n upon xn upon x square minus 1 to the power n. This is called Rodrigues formula. It is said that it is equal to this. This is our Rodrigues formula. So let's try to prove it, and we will show how it work on it. Okay. So proof. We are going to prove our third proof. We know that x to the power 1 by n equal to ncr minus 1 or x to n minus r. Okay, that is from the binomial theorem. We know this. So after that, what do we know? D by x equal to x to the power m if m less than n equal to 0, or case 2 m greater than equal to n d by xm equal to m by factorial upon m minus n factorial x to the power m minus n. Okay, we have shown it. Now let's assume that case. Now that is the case. Now we know from the legendary polynomial. We know from legendary polynomial. If you have written it, I am going to erase it, and be careful. Now this, before starting, n by 2 is even. N by 2 is even for n minus 1 is odd. We know this. Now replace summation r tends to 0 to infinity by n to 0 to n by 2. Okay, when we replace it, we get 2 to the power n factorial x 1 by n r x square by 1 n 2n minus r 2r by minus n upon summation n 0 to infinity by 2n and n factorial by r factorial x to the power 2n minus 2r n minus r factorial. So which give us 2 to the power n factorial summation n 0 to infinity x square by 1 n minus 2r minus 1 by r n factorial r factorial n minus 2r factorial into factorial. So that is our what So the P and X, we have seen it, how to prove it. So I write down it. Yeah, you are easily prove it. Now let's find a general formula of an Rodrigues polynomial. So general polynomial of an general version of an Rodrigues polynomial. General form of Rodrigues polynomial. So P0 equal to what? P0 equal to 1, obviously P1 equal to, we know, d to the power 2 to the power 1 into 1 factorial d by dx x square by 1, which gives us x. P2x is equal to 1 by 4. 2 factorial equal to 2. So d by dx equal to x square by 1 square. So which gives us 8 upon d by dx 2x square by 1 into 2x. So 2 and 2 will give us 4. So 4 upon d by dx x square by 1. That gives us x cubed into x, which gives us 1 by 3x square by 1. So that is our P2, which is easily remembered. P2 equal to x. P cube x equal to 1 by 4 d x into d by dx square x square by 1. What is this? Now let's find a derivative of this. So d by dx equal to d by dx x square by 1 cube. So okay, we remember first is 1, second is x, third is 1 by 4, 3x square minus 1. Now I am going to derive it with 4. Fourth one, remember it. So what will give us? D by dx 3x square 2 to the power cube into 3 factorial 1 2 d by dx into d by dx. So 8 into 24, 8 into 24, 3 into 6. So 3 dx by x square by 1 1. So which after that you calculation you find it. So that's for today guys. I think you enjoyed and I hope you know